in this video, we're going to talk a little bit about subtracting integers. Positive and negative integers, similar to what we did in our office hours last night, but I wanted to go through some examples and explain again what it means to add the opposite when you're subtracting with integers, what that looks like in an equation, and also what that looks like on a number line. Okay, so we're going to start. These are 4 different equations, all involving 4 and 5, but we've mixed up the positives and the negatives, so that you can see that in all 4 of these equations, our strategy is going to be to add the opposite. Okay, remember, the additive inverse is the opposite. It's what would cancel that number out and make it 0. So the opposite of a number is opposite from it on the other side of 0. So the opposite of positive 5 is negative 5. The opposite of positive 4 is negative 4. The opposite of negative 10 is positive 10. And that's really important to understand the additive inverse when we are subtracting with integers. So in the first problem here, we have example A. We have 4 minus 5. The 4 is positive and the 5 is positive. We're subtracting. Okay, so we're going to add the opposite, just like I said. Okay, so we leave 4, and we're going to make 2 pencil marks. Today I'm using a marker so that there's different colors so that you can see exactly what it started as in blue and what I'm changing it to in orange. It's the same equation. This is just how we solve it. So we're going to add the opposite. Okay, so instead of minus, we turned it to plus. Instead of positive 5, now we have negative 5. Okay, so now we have 4 plus negative 5. We go back to our rules, how we add integers, and we think, okay, well, their signs now are different. So we know in our heads we're actually going to subtract. 5 minus 4 gives us 1. And then we look at which one of these would be further away from 0, which one has the bigger absolute value. And it's going to be negative 5, because it's 5 units away from 0, which is more than 4. So that is the sign we keep. Okay? Positive 4 plus negative 5 equals negative 1. Right? Another way to think of it, if adding the opposite doesn't make sense to you, or just you want an easy way to remember it, is to think keep, change, change. We keep the first number, we change the operation, and we change the sign of the second number. Okay, so we're going to look at part B here. It's a different equation. Again, with 4s and 5s, the original equation is in blue. Okay, we're going to add the opposite, or keep, change, change. Negative 4 minus 5. We're going to add the opposite. Remember our 2 pencil marks. Now we have negative 4 plus negative 5. We think about how we add integers. Negative plus a negative equals a negative. And we add like normal. Okay. Negative 4 plus negative 5 equals negative 9. We added like normal and we kept our sign. All right, keep, change, change. Okay, now for part C, we have negative 4 minus negative 5. Some of you may have already picked up on this, but when you're subtracting a negative, it turns into strictly addition. They cancel each other out. Okay, so we're going to add the opposite again. Add the opposite. Now we have negative 4 plus 5. Okay, their signs are different, so when we're adding with different signs, we actually subtract. 5 minus 4 is 1. Okay, but here we keep the sign of the number with the bigger absolute value. Positive 5 has a bigger absolute value than negative 4, so we're going to keep the positive sign. So that's why if you look at part A and part C, they look very similar once you keep, change, change, or add the opposite. But in part A, negative 5 has your larger absolute value, so your answer is negative. In part C, positive 5 has your bigger absolute value, so your answer is positive. Okay, in just a minute, we'll look at how that looks on a number line so that makes a little more sense to you visually. Part D, we have 4 minus negative 5. Keep, change, change, add the opposite. Positive 4 plus positive 5. We add like normal and keep the sign because they both have the same sign. We end up with 9. Okay? Alright, now what we're going to do is look at these problems, 1 or 2 of them, on a number line to see what that visually looks like. Okay. sketching this number line freehand, so it might not be exactly accurate. Okay. Alright, so we have positive 5 down to negative 5 and 0's in the middle. Okay, remember that this equation originally was 4 minus 5 before we added the opposite. Remember they're the same equation, but for visual purposes I want you to be able to see what this looks like. Okay, so we always start with our first number, just like we talked about in office hours last night, again with the green arrow. We're going to start at positive 4 on the number line. Okay, we are subtracting 5. Subtracting means you're moving in a negative direction, you are taking away. So that means we are going to go left. Okay, if we had already changed this to plus and negative, remember this is the same equation, it's just visually looks different because we've changed it to addition. It's the same strategy on the number line. You still start at number 4, which is your first integer, and it's positive. You still start there, that's your starting point. We're adding a negative number, moving in that negative direction to the left. Okay, now this is telling us how far we're going to go, which in this case is 5 in a negative direction. So we start here and we hop down 1, 2, 3, 4, 5, and that's where we end. And there's our solution, negative 1, negative 1. Not all of you may need to do this, but it's important for a few reasons. One is that if you have a word problem that gives you the number line and not all of the rest of the details, you can see on the number line what you're doing. For example, if it's above and below sea level, if it's a temperature above 0 and below 0, and you just have a thermometer, it's good to be able to understand that that's actually a number line. Another way, always, is to check your work. To decide if you've added the opposite, but you're still feeling a little confused about the rules, to think, okay, let me go to my number line. Real quick, just let me sketch it and make sure that I've ended up at negative 1 in the same spot. It also helps you decide if a number is positive or negative and if you have the right answer. All right, let's try one more on the number line. Let's not say b because it might be different from what we were doing before. Okay, let's start with a negative this time. All right, so now let's say we have negative 4. Oops. Negative 4 minus 5 equals, right, we'll draw our number line out. Okay, 0, 5, 10, negative 5, negative 10, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. Okay, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so negative 4 is our first number, so that's where we're going to start on the number line. It's like you're giving directions. That's your first direction. 1, 2, 3, 4. Negative 4 is where I start. Okay, I am minusing 5. I'm taking away, so I'm moving in a negative direction. So I'm going to go to the left. Again, this is telling me how far I'm going to go left. Right, this is the first part of your directions. This is the second part of your directions. If you had already added the opposite or done keep, change, same thing. We start at negative 4. We're moving in a negative direction to the left. Okay. So we're at negative 4. 1, 2, 3, negative 4. We're moving 5 to the left. 1, 2, 3, 4, 5. And where do we end up? At negative 9. Right here is negative 10, so this one right here would be negative 9. Same as if you had solved the equation like normal. Negative 4 plus negative 5 equals negative 9. Alright, those are just a few examples. I hope that this helped. And please, please, please email or call me if you have any other questions. Good night.